Be more on the milling machines, and milling machine usually consists of three dimensions. I mean, three coordinates: x, y, z. But here I'm going to highlight just some example about the lathe machine for turning center. So for the lathe programming here, the difference will be in the definition of the coordinates, as we learned before when we talk about the absolute coordinate and incremental coordinate in chapter 2. We see how the coordinates for the lathe machine will be defined. I mean, for when we talk about the lathe or turning center, the coordinates will be defined for the cylinder or cylindrical shape from the center of this cylinder and to the top, for example, either on x-axis, then go to the z-axis, or on the z-axis, then on the x-axis, because it consists from only two, two dimensions. So for the lathe programming or the turning part, you are required to understand, as I gave you in the assignment, how to find the coordinate for the cylindrical shape. So here we are going to go through with a simple example for the lathe programming only. Regarding the G code, as I told you also before, some of the G code only used with the lathe machine, I mean with the milling machine, and is not applicable for the lathe machine. And there is some use for the lathe and not applicable in the in the milling machines. So for the CNC lathe here is a machine designed to remove the material from stock that is clamped on and rotated here. So usually the machine or the workpiece, unlike the turning machine, the CNC machine, the milling machines, the workpiece is placed on the table of the machine. Then the spindle is come from the top, either to create drill or for milling and so on, to perform the different milling operations. In the lathe here, the part will be fixed in the machine, and usually the part is a cylindrical shape, and the machine cutter or the machine tools will go through while this part is rotating. Rotating means it will because since it is cylindrical shape, so it need to cut the shape from all sides. I mean, in a rotating part, since it is a cylindrical shape, as we will see later on. Okay, most of CNC machine are used for for holding, changing, and moving the tools. This is how it's work. And CNC machine or CNC lathe machine use Z-axis and X-axis here. One of them is towards or away the spindle, and the other one is toward or away of the workpiece here. The seven most important lathe operation here: facing, turning, grooving, parting, drilling, boring, and threading. As you can see here, drilling can be used for both, and also some of facing used for both, either in CNC machine, at milling, or in turning center. It's all the same. So modern CNC lathe here in turning center utilize indexable insert cutting tool. So even if you try with your with the simulator, you can see different type of the tool. Like left, some tools they come with the cutter on the left, some tools with the cutter on the right, some tools with the cutter on the top, and so on. Also different size of cutter and different purposes of these tools. The speed of lathe here rate is a point of revolving because we are talking about the spindle. Which is not only the we're talking. It's not like in the milling when we say the spindle is rotating and so on. Here the cutter machine or the cutter tool is come near to the part, and the part is rotating. So here the speed of the lathe is the rate of which point on the revolving circumference of the work passed through it. So it's the tool itself, the workpiece itself, which will be fixed and it will be rotating. Also need to define the feed rate and also the speed here. Also the depth of cut on the thickness of the material. Since we are talking about the cutting for in the lathe case, also there is a depth for cut on the material itself. Right-handed and left-handed cutting tools also have their cutting edge either on the left side or on the right side. This is how the workpiece will look like in the case of the lathe programming. I mean, the workpiece piece usually is a cylindrical, and there is a center for this workpiece, and above there is a either diameter or radial, and also down here we have diameter or radial. I mean, the dimension will be defined in such a way for the cylindrical part of the lathe programming machines. Here is an example also. What are the operations that is required? For example, here we have the main operation. Then we have the parameter setting for the speed and also for the type of, I mean, either absolute or incremental matrix or inch. Then we have also the same, we have linear operation, we have fast spindle, we have linear operation, we have fast spindle, and so on. All these just used to, as you can see, G01, G01, G01. So G01 here move the tools towards the body of the workpiece, and the workpiece, and it will cut it in a surrounding of the workpiece from outside. The same in this case, also cylindrical part, here also cylindrical part. In all cases, we need to define the coordinates for the movement of the workpiece and the touch with the in the movement of the workpiece and the touch between the workpiece and also the cutting tools will be the same. So need to define these coordinates using the radial or diameter coordinates method as we learned before. As you can see here, in the simulator here, we have this simple example for radial. This from the tutorial of the machines of the simulator. As this is the part that need to work on. So this part will be fixed on the machines, and the cutting tool that will be selected, as you can see here from involved part, you can select the cutting tool here with for this left hand roughing. You can select a lot, different tools here, left hand finishing, left hand triangular straight stream, and so on. So you can select which material or which of the lathe tools need to be used here. So just keep it for the one that we have before. Then this is the workpiece that we have, or with a specific dimension that we select. As you can see here, this is the workpiece for lathe. I mean, the one that we have for lathe workpiece here. This one is the cylindrical piece with this diameter of 50, length of 100, and inner diameter of 0. That means it's solid. It's not. There is no hole inside. So it is a solid cylinder here. So this part will be used or will be fixed in the machine when we execute this program, and it will create this the cutter will cut around this machine. So as you can see here, you just run, it was cylindrical before, and the cutter is come to create these parts. So this is the main operation of the lathe. So the lathe, for example, it was to cut this part, depends on the requirement. This at specific speed, at specific depth, and here is the dimension. The cylindrical here values or the coordinates or are defined here. G0, for example, G01, Z60, G01, 59, G01. All the movement when the machine is rotating, the machine or the part is rotating, and the cutting tool is come here to create based on the specific dimension that we have here. So this Z60, Z62, and X, you can see here we have only two dimensions, which is the coordinate for X and the coordinate for Z, since it is cylindrical. And as we mentioned before, we need to define this dimension based on the specific diameter or radial of the cylindrical piece. Also here we have drilling at the end. At the end we use drilling for G01 for the drilling cycle here to create this hole. Again, as you can see here. Okay, so this is about the list programming, and usually if you will be asked about this part, you will be asked about how to find this or how to define these coordinates from the z-axis. I mean the z-axis to the x-axis. Z-axis is the horizontal one, x-axis is the vertical one, and you can see it depends on what is the diameter here, what is the space. So based on the diameter, you are going to define the different points on this workpiece. As I told you before, you have one example about this one in your assignment. So also previously in chapter 2, when we talk about the incremental and absolute coordinate, we highlight how we can find either for radial or for diameter. For diameter, we said we need to multiply by 2. For radial, we just talk about the half part of or the top part of our work piece here. So this is a simple program also used to create this shape from the original shape, which is a fully cylindrical part. So we need to define different coordinates with different type of code, G00, G92, G96, G01. But mostly we use either, if we have linear, so we are going to use G01. If we have a circular, we are going to use G02 or G03 based on the requirement from from the shape or from the drawing itself. This diameter will or these dimensions will help to define the coordinates for this point, that point, that point, that point, and so on along this surface or these drawings. Okay, so this one example about milling machines again. So this is just a complete example to show you how to write a program for the milling based on given drawings with some information here. So this example, the machine procedure is to mill around the outside. So that means we have a workpiece and around, we want the spindle to go around this or the outside of this workpiece to create this shape. That means your workpiece, for example, if you want to try this example here, you need to have your own workpiece which is rectangular, fully rectangular with the dimension which is more than these dimensions. Then you need to create your own, on this workpiece, you are going to give the program or to develop the program to cut around these dimensions with the, for example, with this length from this point here until that point is 1.5. From this point until that point is 2.5. That means this width is 2.5. And here is the length is from this point to that point is 4.5. So, this is the width is 2.5, 4.5. And here the length is, the width only 1.5. Then here we have 1. This 1.5, this will be 1. Okay. So you need to define the different points here, starting from the reference point, which is number 1, move to point number 2. Then from point number 2 to point number 3, you are going to use the G01 because it's linear movement. From 3 to 4, G01. From 4 to 5, G01. From 5 to 6, G01. To 7, G01, and return to the last point here. The tool here that will be used for milling, which is half the diameter of half, and the thickness of the workpiece will be, or the thickness of the hair will be 0.2 for the steel. Here's some information which is given: 0.5 inch deep. This is the deep of the cut, and here we have 5 inch per minute, which is the feed rate. So the program that will be developed based on this given information plus the information that you have from this figure. Your task will be first, before you write the program, you need to list out all the coordinates for movement or for the path of cutting or the path of drilling and making holes. After you define these dimensions, point 2, what's point 2, what's x for point 2, what's y for point 2, what's x for point 3, what's y for point 3, and 4, 4, 5, 5, 6, 6, and so on. Then after that, you are going to see, is your path is linear or circular? Do you have any holes you need to create here for drilling profiling, or you just have linear profiling or circular profiling? Okay, after that you start to develop your program. The program should consist from the part that we already mentioned before. As we told you, this is header or setup operation of the program. Then we have the body or operation of the machine. Then we have the ending of the program. So here the header that define the program number or program name. Then we have to define the absolute or incremental here. I mean in addition to absolute and incremental, we need to define matrix or range. We need to define the plane. If we have sometimes if we have we need to define the plane. Is it X or Y, or I mean XY or XZ or ZY? You need also to define the G40 here to cancel for the compensator, or to include left compensator or right compensator. In this case, cancel. That means it will just use the existing coordinates here. Okay. Then if you need to cancel the drilling here, so there is no drilling operation inside. You need to define G28, which is the 0 point for Z0 here. So the spindle will go to G00 at Z0. The tool that you are going to use, we have only one tool for cutting. So just, I mean, for milling, so we are going to use one tool. Then we have to define these other metrics before the movement for the, or before the movement for the first operation at the point one. So you need to see what's that type of coordinates, what is the speed of rotating for the spindle, okay, and what is the compensator for the spindle. Then the spindle will move to the point one. So what is the coordinate for point one here? So point one coordinate is -1 and y is -1. Why -1 here? Because as we said here, for example, for -1 point, I mean, if we do not consider uh, if we do not consider the diameter of the cutter here, we just ignore. So in this case, we just put the exact point of the spindle without ignoring the without compensating the diameter values. So the spindle here will move to 0 to the top of, I mean, to the I mean, like the standby position, Z1 here on top of the workpiece. Then when it's go for cutting, when we use the cutting here, G01, we start to make for the depth is 0.5. For it will go for the -0.5 of Z here. So for 0.2 here, then it will continue G01, go to X0, X0.25, X.45, Y.1, and so on until complete the 8 values. I mean, all these parts here, for starting from 0.1 to 0.8, you just place the cutter on the border of this workpiece, then go to cut by using the G01. All this you can see here, G01, because all are linear profiling. Starting from here, G01, this one is also G01. The two previously, the previous or the main two part here, just to move to the point number one. So the spindle here will move to the first point. As I told you, the first part or the first task will be for you to find the dimensions. And for this example, maybe there is no a lot of details, but usually either for the test or for the exam, you will be provided with some figures which more details. More details mean like the one that we have here. So for such example here, you have all the details about the dimensions for everywhere. I mean, you can see here 8, 15, 26, 55, 45, 33, 22. I mean, you can decide or you can find, unless it's listed there. I mean, although it's not listed some of the dimension, but also based on some symbol calculation, you can find the rest of values like we did in the previous for linear profiling and circular profiling. So the coordinates is much important. The first is the coordinate. The second is the type of the model G code that you are going to use. For example, if I give you linear and you go to use G02, so for sure this your answer will be wrong. If I give you circular, you go to use G00 or G01, for sure it's wrong. So I mean, the main thing for in such to write the G code here is first is to define the coordinates of the points. The second is to select the suitable G code. The third is to define the specific, type of coordinates, the specific type of matrix or measurement. If I give you the measurement in millimeter, you got to use inch. So this for sure it will be wrong. So you should consider all these parameters from the given examples in your calculation. Also the feed rate, the speed of the machine, and so on. Okay. So the last here, G00 to Z.1 to the first, you go to the reference point here, then you stop the program, or you end the program here. You go to the reference point and you end the program. The program should have start, header, and should have end, which is for to end the program here. And in between, you have the body of the program. So your work or your coordinates will be defined clearly in this part. Any question about example number 1? As I told you, you can adopt these dimensions to a suitable workpiece on the machine that you have, on the milling machine center that you have. So you can create such shape here, even with different dimensions. Try to use your own dimension which is suitable for the machines. So for this program here, if you go to create some for milling, like this one. Sometimes if your dimension is not suitable, if you do not select the correct dimension, because the machine sometimes it has some limitations, so it will show you such error, incorrect parameter, incorrect, like this. So this one. See, for example, in such case, this is the workpiece is much more than the table of the machines. You can see this is the machine table dimensions, and the workpiece here is more bigger. You can see the workpiece is outside. So what I ask you now to do, I want you, in order to test all the examples that you have in the slides, to go through to see how this example is work and so on, you need to re-select the dimensions to be suitable for the dimension of the machine. Try to use like 200 times 200, or sometimes because for the y-axis, it's not allowed for you to go for the left side. For the negative side, for the y-axis, you are not allowed to go for the positive side of z-axis and so on. So there are some limitation in terms of the simulator here, because this code that developed for real machines, but in order to simulate or understand how to simulate this one, you just need to readjust some of these dimensions that you have on your drum. Then it's for this part, for example, you need to go inside y, then go right, then go down, left, down, and return back to the reference point. So it's not that difficult to be tested by using the simulator, but only avoid to use or try to use the correct dimensions, which is suitable for the machine, and also try to adopt. For example, there is given in inch, so just use in millimeter, or you need to select or change your setting into millimeter and so on. For example, 2 here, referring to the following figure here, coordinates before starting cutting is at the point x -5, y -5. So this will be the, I mean, before starting the cutting, or the like the reference or the initial position for the cutting here. Then the first part will go to P1, P2, P3, P4, P5, P6, and then return to P1. And you can see here the cutter or the milling tools, how it goes through the part. So the original part or the workpiece will be with the dimension on the outside here, and here inside will be the movement of the machine, I mean of the tools, to create this part, which is, I mean, we with which is start from B1 and then return to the P1. So this outside dimensions for the length is 55, and for the y-axis is 45, and in between you have some position. So that means the machine will go linear, or the cutting tools here will go linear from B1 to B2, then also linear from B2 to B3, linear to B4, B5, B6, and return to P1. So the match, it's very easy to have such type of examples, I mean of questions, because it just depends on one type of code, which is the linear profiling. But if some example, you are going to see some mix between linear profiling and also circular profiling. So here also I give you the speed, I mean the thickness is 10 millimeter, the speed is 1300, the feed rate is 50, and also the diameter, the tool diameter is 2 millimeters. So the tool diameter here, in the case you want to compensate or you don't want to compensate though, so this up to the program that you are going to write. If you want to compensate, so you are going to use either G42 or G43. If you don't want to compensate, just use the G40 as a non-compensator. So the same here, this is the program we start with, I mean, include the header and also include the tile here. So the header will define the program, define the main parameter, the speed, and also the type of the movement for the reference point. Then in the end here, just to cancel the movement and return the spider to the position, to reference position, and then end of the program. In the body here, you need to define the coordinates for all these points. So as we can see here, starting from B1, first is G01 for Z -2 at feed rate is 50. So you go for, I mean, on top of the workpiece with the depth of -2, because he said here the depth is -2. Okay. So also the tool diameter here is, I mean, is 2 millimeter here, and the speed is 1300, and the feed rate is 50. So all this one feed rate is 50, and this one for the cutter for the diameter, the depth of the diameter here to go inside the workpiece. Then you start define the first point, x3, y6, x0, y24, x12, y90, y9, and so on until finish all these points. So also this example can be applicable to the simulator. So you can try to adjust the dimension here for your workpiece. Okay. So and then try to create the points or define the points according to your new workpiece coordinates. I mean, it's not compulsory to use the same dimensions. You can adjust your dimensions and you can create your own code. Another way, in order to use the same dimensions here that you have and so on, and to avoid the writing the code, you just need to draw this figure by using the this part here. You go here for SimCam, you create this figure with this dimension, then you draw your contour here. Contour, that means you are going to draw the path for your cutting tools, and you select your cutting tool with the same parameters. Then after you create this cutting, you create your contour, it will generate your code here. Like we have, like I told you last time, you have some of examples here for demo here. So you have in millimeter and you have in inch. So such example here, it includes some of the, it's already like drawing here and with layer, and we already defined some layers and so on. So when you run, when you create your own code for this part, sorry, I just close this one. So in order to create your own drawing, your own code here, you need to go for contour, and you need to draw the dimension, or the path for your workpiece. You need to define your workpiece. You need to create after your layer here, what type of layer that you are going to create. So you can select from here either drill or bucket or contour and so on. So based on these values here, or based on this layer and the definition that you are going to get, you are going to create your own code. The code will be generated from figure, not the, you are not going to write the code, then you got the figure. No, it's like opposite. You are going to draw the figure, then you are going to get that code. So I want you to try all these examples that you have in this chapter. Adopt the size of the workpiece, adopt the size of the, or the dimension of the coordinate, and try to use the simulator to work with it. Okay, you create your own workpiece, okay, with the specific dimensions. Then inside this workpiece, you can try to create the other shapes here for this, for this figure, by using the same code here. The code will be the same, only the difference will be in the coordinates of the point. So where is point 2, point 3, point 4, point 5, and so on. So the dimension will be different, but the code will be the same. You are going to use G90, for example, G91, G0, G01, G02, G03, and so on, but to generate a different. Also here, for example 3, it's just combined between the linear profiling and circular profiling, because you have one part here about the circular profiling. The same way here, the question is referred to the figure for coordinates, and the position is -10, -10 for x, and y is what, like the start point here, as this point is -10 and -10. So this is the 0 point of the workpiece, and this is the 0 point of the machine or the spindle in the beginning of the work. Then the spindle will move to the first point, for example, and go to the second B1, then B2, B3. This is B1, B2, B3, B4, 5, 6, 7, 8, 9, and return to B2 again. You have some of the dimension here. So this dimension will be used to create your coordinates for the workpiece. And after you create the coordinate for the workpiece, you are going to generate the code for this workpiece. So this is the example here. This is the program, how it looks like. So in this program, the header and the tail is the same, not change. Only you have the, in the body here, you have the change. So in the body, you are going to use, for example, here G01 for Z -15, F15. So this is based on the given information here. For the speed is RM 800, and for the feed rate here, cutting thickness is 15, and the diameter is 5. So the feed rate is F is 150, even it's not given there. Okay, so then you have to start the movement for all different points, N1, B2, B3, B4, B5, until you end the B movement. You can see here for the G03, we use it here. This G03 because it is counterclockwise. So we use a circular profiling, but with a different, with counterclockwise. It's not G02 because G02 will be clockwise. So here in the G03, we define the X and Y, we define also the R value, which is 20. So you have two options to write the circular profiling. Either you define X, Y, I, and J, or you define X, Y, and R value. Then it's continue to this point. Hopefully next class we are going to apply some of this tutorial by using the simulator and to generate some code from existing drawings. Okay, but before that, I hope all of you already installed the software and try to use it, because you will use it for your assignment. Okay, and your assignment will be 15% of your Karima, and it will be in the groups that I distribute you before. The assignment area will be like giving you some of the figures and asked to write that or to generate the G code by using a suitable simulator. It's up to you. You want to use the simulator, or you already install any another simulator and can be used, so it's okay. The rest of this chapter only you have some exercise. I already have give you exercise and also provide you with the answer for this exercise. Okay, you can go through, try to adopt, try to change the size and use the simulator to generate, to execute the code to confirm that this code is correct or not. Okay, you may have the same shape but with a different dimensions, or you may have the same shape with the same dimension. If it's okay, first you try it with the same dimensions. If it's okay, the machine not or the simulator not give you any error, so okay, you can proceed. If you have some errors because of the dimension, he said, for example, the y-axis only from 0 to 200, the x-axis only from 0 to 340, and so on. So try to adapt your figure to find a suitable dimension for each one of these figures and generate your own or you develop your code with the new coordinates, so to execute and conform it give you the same figure. Otherwise, you may draw these figures by using the sim cam, and then create you draw it like this one, you highlight the dimension and so on, then you use the contour to draw how the path of the cutting machines, then the code will be automatically generated there. You can see here from the settings, the same cam here, you can see create CNC code automatically. That means when you create the shape, it will generate one of the it will generate for you the G code. There is one tutorial here you can follow in order to generate the G code. This one, SimCam tutorial 1 for milling. This gives you some dimensions here, how to draw the circle and so on. Then after you draw the circle, you insert the layer, different layer, you define your tools, then your code will be generated on the right side here. It will be automatically generated for this work bar. So you have two tutorial for milling, and also you have for turning tutorial, and you can read this part also for related to the the SimCam, either SimCam layers or starting from SimCam bucket milling, drilling, steaming, and so on. All this related to the part of the SimCam tutorial, the SimCam user guide, starting from this part. This one, SimCam number 12. So from SimCam number 12 here, it shows you also there is some demo. This one you can find it directly in the demo of the file. You just open the demo file here. You go there down, open some of demo files. You have some in inch and you have some in millimeter. This is for milling. This one, for example, here. Actually, because the setting for the workpiece is not the same, but it can generate the same shape. This type of the code here, which is generated directly from the figure or from the SimCam here, it show you how, and this is line, we call it the contour. You draw the contour by using this one contour, so you highlight from which point by using track. So you just highlight this point, for example, and then move. You need to draw your own track for or your own path, starting from this point where we are now, then go to that point, go to that point. So contour that we highlight or we talk about it in chapter 2. I mean, we it's like to generate multiple coordinates for the spindle to go through in order to create. And when you finish to create the contour here, you are going to see the code for this program. And this code actually will be, or this CNC code, if the workpiece is suitable for this one, so it can be easily generated. Okay,